In this video, I'll be talking about the root mean square velocity of a gas. So, root mean square velocity, or for short, just URMS. Although some people usually write it as V instead of U. R, no parentheses. RMS. And the formula to obtain the root mean square velocity of a gas, so I'm just gonna write it as U. RMS is square root of 3 RT over its molar mass. I'll be writing molar mass as that symbol because I don't want you to get confused if I write it as a big M and consider it molarity. So that's the molar mass. And let's talk about the temperature is just the T. So T is temperature. And well, the R, we talked about the R. We said that the ideal gas constant, or the R, is 0.0821 liters atmospheres mole Kelvin. However, there is another value for the R. It's the same R. It's still the gas constant, but it'll have different units. That's why it has a different value. It's 8.31. Let me fix this. 8.314 joules over mole times Kelvin. Now you may be asking yourself, when do I use the R that is in liters atmospheres per mole Kelvin, or the R that is in joules per mole Kelvin? You will want to use this R when you're dealing with energy and velocity. So in this case, we will be using this R, this one, for this. And you can remember that just by thinking, well, energy is in joules, so this R has this joules here, so that's the one I'm going to use. When you're dealing with pressure, you'll want to use this R, this one. So, pressure. So we have our R in joules per mole Kelvin, so that means that our temperature will be in Kelvin too. But this is where most people commit mistakes. The molar mass cannot be in grams per mole. It has to be in kilograms per mole. So remember that. It has to be in kilograms. And I'll show you why. One more thing I forgot to say is that this formula, you can obtain it using two different formulas. That's kinetic energy and molecular velocity, but that doesn't really matter for this video. As long as you know the formula, you'll be fine. So now let's explain why the molar mass has to be in kilograms per mole. We said that our formula is R, and let me write this for it first. 3RT over molar mass. So let's write our units. We have our square root here. I'll make it really big. So our 3 here is just a coefficient, that doesn't matter. Our R is 8.314 joules per mole Kelvin. And our temperature is in Kelvin, so just X Kelvin. Over the molar mass, we'll call it Y, kilograms per mole. Don't worry about the X and the Y. It's just saying that represents any number. It's a variable. So we see that the Kelvin will go here, and the moles will go here. But then we're left with square root of don't worry about the number, joules over kilograms. And if you remember, a joule is a newton times meters, and we have our kilograms down here, so this is what we have now. And a newton is kilogram per meter over second squared times, we have meters here, over kilograms. So this kilograms will go, and we will be left with the square root of meters squared over second squared, which is just meters per second. Those are the units of velocity, right? So that's why we have to use kilograms. If we don't use kilograms, we will have grams here instead, and the kilograms won't go with the grams, and our units won't work, and the numbers won't work as well. So always remember, you have to use kilograms to solve a problem, for the square root to work. Now let's solve a problem using this really quickly. You want to calculate the square root mean velocity of the root mean square velocity, sorry, of an atom of a sample of oxygen gas at 30 degrees Celsius. So we have oxygen gas and the temperature of 30 degrees Celsius, and we have our constant here. It's 8.314 joules per mole Kelvin. And they're asking for the URMS. Now let's write our formula. And it's not a U. Okay. Square root of 3RT over the molar mass. So we have to find the molar mass of the oxygen gas. So they told us that we only have 1 mole of the atom of oxygen gas. So we start with we have to write our grams up because we want the molar mass, so it has to be in grams per mole, or in this case kilograms per mole. So a diatomic atom of oxygen, or molecule of oxygen, has to be 16 times 2, so we'll just say 32 grams, and that's one mole. And we want it in kilograms, so a kilogram is 1,000 grams, so 1,000 grams is 1 kilogram. So this goes with this, and our units are kilograms per mole, so it's fine. So 0.032 kilograms per mole. Now we simply plug in the values to obtain the root mean square velocity. So RMS will be 8.314 joules mole Kelvin. And the temperature is in 30 degrees Celsius. You have to change the units for that. It has to be in Kelvin. So 303.15 Kelvin. And it doesn't fit in here. Over 0.032 kilograms per mole. Look to an arrow here. 303.15 Kelvin. And I get square root of a very big number, 286 meters squared second squared. Let me make some space in here. Just by getting the square root of that, I get 486.093 meters per second. And that's how you solve a problem in which they ask you for your root mean square velocity. always remember that the molar mass has to be in kilograms per mole, and your unit should be fine.